these objects are having reduced availability with no rebuild, and that there is a delay timer. Okay, so this means that the objects are not, they are still accessible, but they do not have all their components available. We're not going to rebuild because there is a delay timer. I will get into details in a moment. So let's now select the vSphere Manager VM. I'm going to go ahead and click on monitor. You can see the status from here as well. So this is not compliant because it doesn't have all its components. If we select physical displacement, in order to take a look at the state of each component, here we can see that some of the components are absent, and we have a new type of component called durability component created. Okay, so we have active, absent. Let me show you something else. Let's exit the maintenance mode and make this available again. So active, absent. Let me show you another one. So I'm going to go ahead and change the policy for one of the, hopefully, busiest disks in the vSphere Manager VM. So let's refresh. Let's keep refreshing. So here we are looking at the state of the components. Okay, it's going to take some time to reflect the changes. Here is another state. Component is in reconfiguring. Okay, so what does all this mean? Okay. So here is another example, reduce the availability with no rebuild. And here are the different states of the components. So first of all, active state is not really visible in the graphical user interface. This is something you would see only using CLI. Okay, I will explain what it means, but you should not expect to see it in the graphical user interface. So let me explain the easiest ones to understand first. Active. Active means that the component is okay, it's compliant, working as it should be, and everyone is happy. That's what active is. Okay. Reconfiguring. Reconfiguring is visible when you change the policy, exactly what I did. Okay, when I moved from red 1 to red 5 or vice versa, if we go back, these components, well, it's still reconfiguring, so it's going to take some time. Looks like it's so if you click on cluster as seen yesterday, we can click on resync objects, and it's going to give us, it's already done, it's already completed. So let's go back here, and yeah, they are gone now. It's now active. So it's something that you should expect to see only when there are changes happening. I'm just going to, apply the policy to all the components again, same policy. If I refresh, we have reconfiguring again. If I go to cluster, then resync objects. And as you can see here, this is how much left to complete the resync. ETA is 6 minutes. You can see here the objects concerned. So reconfiguring is visible only when the components are going through a policy change procedure. Okay. Once they finish, no more reconfiguring. They will become active. Next, we have absent and degraded. Okay. It's completely different. The two may seem to be the same thing, but it's not really the case. So let me start with degraded first. Degraded will trigger immediate resync of the data. Okay, what do we need by immediate resync? Still, you have 4 hosts, right? You have 4 hosts, and you're experiencing a failure. So host 1 with a component, host 2 another component. Then we have witness. Host 4 is not having any issue. You just lost host number 1. The component is degraded. This means we will immediately start resyncing. What do we mean by resync? We will simply create a component here starting from the remaining 2 components. Okay? That's what degraded is. Okay? Degraded is actually visible when you have a failure reported. What do we mean by a failure? It's actually something that vSAN thinks cannot be fixed, or at least cannot be quickly fixed. Example of that, a disk failure, storage controller failure. Okay, this will require some downtime, removing the controller, changing it, recreating the disk group, stuff like that. It's going to take some time. Okay, a disk failure. If you are wondering, how can vSAN know that the disk failed? Well, we use completely transparent storage controllers. We call them HBAs, host bus adapter. It's basically similar to a RAID controller, but without RAID capabilities. So it's completely transparent, lets vSAN see the disks. So vSAN can talk to the disks. That's why, by the way, vSAN is really entirely based on hardware compatibility, more than the vSphere itself. So since the disks are fully compatible, vSAN can talk to them. It can know if there is a failure, critical failure. Okay, so that's what degraded is. Degraded immediate resync. Of course, resyncing if you have resources for that. In the example I showed you before, we have 4 hosts for a policy of RAID 1 with an FTT of 1. You have 1 additional fault domain, 1 additional host that you can use for rebuilding. So what is absent then? Absent is going to be visible if vSAN thinks that maybe the component is going to show up very soon. Let me give you an example. Someone, by mistake, removed one of the physical disks from one of the hosts. Okay? So vSAN, again, can know that the disk was physically disconnected. It's not a failure. It's not someone trying to erase or whatsoever. It's a disk that has been physically disconnected from the host. What will vSAN do here? Well, it's going to mark the component as absent. It's not degraded. Okay? So the component was active. It's going to be now visible as absent. And vSAN will wait 60 minutes. Remember that number we saw in the advanced settings? That's the default value, 60 minutes. Okay? vSAN will say, okay, let's wait for this guy to come back. Maybe he's going to be here in 15 minutes. Okay? Maybe the admin that has by mistake removed the disk will figure out that it's not the correct disk that must be removed, and he's going to connect the disk back. What's the objective here? The objective basically is that we don't want to start resyncing for nothing, because a resync may involve moving a large amount of data through the vSAN network. You can just imagine someone disconnecting the cable, the network cable, or the 2 network cables of a network card of a host. The host is completely disconnected. The host has like 10 terabytes of data in it. Just imagine the need of copying or creating 10 terabytes somewhere else. We don't want to do that for anything or for any reason. We really want to keep that for critical situations where the resync is really required. That's the idea behind this. Okay, default value is 60 minutes. But wait a minute. There are a lot of things that can happen in 60 minutes. Okay, so let's see what can happen. Here's my host containing the components that went from active to absent. I have additional hosts, have another component here, and I have my witness placed here. Okay? Well, actually, the component was absent for 30 minutes. During those 30 minutes of being absent, there was, a lot of data written to this component. We kept writing to this component. Okay? So even if we restore the original component, it's not going to be up to date. That's the reason why vSAN will create something called durability component. Okay? This used to be called Delta component in very old documentation. Now it's called durability component. What is this durability component? Well, the durability component will be created to capture all the writes when the original component was absent. Okay? So if after 30 minutes, for example, our original component is now okay, it's not going to be active, but it's going to be active stale, which means I can see it, it's here, but it's not up to date. So let's start a resync between these two components. So I can take those captured writes and add them to the original component so we can revert back to active. Okay? Make sense? Does it make sense, guys? Any questions? Okay. So let's do something. Just to see how much you can remember from this. Okay, so let's simulate that we have this environment. 1, 2, 3, 4, 5, and even 6 hosts, right? Okay, we have VM1. It's got component here, one here, and one here. Okay. Then we have, may I change the colors? Okay. Okay, here is VM2. So VM2 is using red one with an FTT of 2. So it's got components, witness components. Okay. Then we have VM3 using red 5. Okay. It has component, and component. Okay. We also have VM4. Okay, VM4 is using red 0. Okay, here's its components, right? Here's VM4. Okay. Then we have Yes. This is VM1 running here. And okay, so it's VM2, VM3 running here. Okay. All right. So I just lost the first host. What's going to happen? Can anyone tell me what's going to happen? We don't really care about what kind of failure is that. Host number 1 is not available for some reason. It's going to happen.
So now that timer's going to start.
Okay.
And then there's going to be a durability component on one of these others.
Okay. So where's the durability component going to be placed in?
I don't know for sure, but I'm going to guess it would be on the same host as the compute part of VMware 2. Or sorry, the VM2. So that third one?
Well, look, the durability component is going to be placed in a host where no components of the same object are placed, which means that for this particular VM, if you look at the colors, it's going to be placed on host number 2. Okay? If vSAN cannot do this, if it cannot find the host without any component of the object which is having an issue, it may place the durability component within a host where a component of the same object is placed, but it's going to place it into a different physical disk. You see what I mean? Let me explain this another way. See, you have 3 hosts. Okay, you have 3 hosts. Component, witness. Okay? You lost 1 host. You don't have any hosts available without the components of your objects. If you had component, witness, you lost the component. There is a component in host 2, component in witness in host 3. So in this case, even though it doesn't really make any sense to have 2 components within the same host, but vSAN will still create a durability component within one of these 2 hosts. So it can capture the writes. Okay. So let's actually let's see what's gonna happen if we continue, or if the 60 minutes are gone. I mean, we waited 60 minutes and Dell is not responding for some reason. No one is answering our calls, and okay. So what's going to happen after 60 minutes? There must be something that needs to change. We're not waiting for nothing. So what's going to happen after 60 minutes? Come on. So I would like everyone to participate. This is how you can learn. And as an admin, this may happen to you. So better to know what you should expect in this kind of scenarios.
So the component that's on the failed host will be rebuilt again.
Yes, that's correct. So the component will be rebuilt here, right? But unfortunately, we lost host number 2 without fixing the first one. So what's going to happen here? I'd like you to give me an answer about compute and storage, both. What's going to happen in this environment? And please keep in mind that this exercise is assuming that in each failure or in each one of the failures or after each one of the failures, we still have some storage available to rebuild, okay? Which is not typically the case in all situations. Okay, so what's going to happen in this case? So let me give you some help. From a compute point of view, VM1 will HA somewhere. Okay. So HA will restart VM1, maybe here. Okay. Let's imagine that it's restarting here because the host is gone. What about the components? We have 3 components there, and they belong to different VMs. So what's going to happen? You will panic for sure, but what should you expect as a result? So let's look at each one of these VMs. The first component, this one, let me use the red color. This one belongs to which VM?
That's VM2.
VM2, okay.
It's sitting on the third host.
Yeah. What kind of policy is that? It's red 1, FTT of 2. How many failures are we experiencing now for this VM?
This is the second one.
But we rebuild. We already did a rebuild. So it's not considered as a second one anymore. We have the 5 components. Look, 1, 2, 3, 4, 5.
So the rebuild did finish before that one failed. Okay.
Absolutely, yeah, absolutely. So this is the first failure. Will the VM survive, VM2? Is it going to continue to run with the data available? What do you think? Will VM2 continue to run? Well, the answer is simply yes. We have an FTT of 2. We only lost 1 component. It's our first failure, so that's okay. Nothing is going to happen. Okay, even the performance here is not going to be affected because it's red 1, right? The object will show up as reduced availability, no rebuild. Why no rebuild? Because we only have 5 hosts left, 4 hosts left. There is no room to rebuild anymore. Are you guys following?
Got it.
Okay. Let's move on to the next VM. This one, component, the black one, belongs to VM1. VM1 was restarted here from a compute point of view. What's going to happen to this guy? Well, we can rebuild somewhere. For example, we can rebuild it here. Wow, we're gonna need to wait 60 minutes and all that story, and then we will end up rebuilding here. Now, the third component that belongs to which VM? VM3, the blue one. Okay, so this one can be rebuilt here. Okay, because we still have this host available without any components from VM3. All right, so let's continue. Host number 3 is gone as well. What's going to happen in this case? We lost host number 3. What do you think? So VM2 will restart somewhere. What about its data? Are we going to continue to access the data of VM2? Yes or no? Yes. Okay. Look at the data of VM2. This is the first failure. This is the second one. FTT of 2. We are good. So if you look at the column, 1, 2, 3 out of 5. So we have more than 50%. VM2 is safe. Okay. Let's look at VM1. What do you think? Is it going to survive or not? VM1, absolutely, yes. So it has one component here, one here, and one here. It can even rebuild. It can rebuild here. Yeah? Assuming that we have enough storage. Okay? For VM3, the blue one. For the VM3, can we rebuild? Yes or no? And is it going to continue to be accessible? What do you think? What RAID is that? RAID 5. How many failures does it support? 1. That's exactly what we are experiencing here. Here are the 4 components of this VM. We lost 1, 3 are left. So the VM will continue to be available, no rebuild. Okay? One last question, and we will have a short break. We lost this host without fixing the others. Could you guys tell me, is there any VM surviving to these failures? VM4, it says VM4. Let's see components of VM4. VM4 is using RAID 0, so it's not going to survive. It's running here, lost the host, component is gone, and VM is gone. VM1, let's see. Components, let me change the color. VM1, components, components. We lost this one, and we have 2 out of 3. So VM1 will survive. Okay, VM2, this is the third failure, gone. VM4, RAID 0, gone. VM3, 2 failures, that's more than what RAID 5 can tolerate. It's gone as well. So the surviving VM here is VM1. Okay, this is just a single example of failure. This is an extreme situation, but let me give you a very good link that's going to help you to to see examples of failures. You can bookmark this one. Sorry for the background noise. I think we have some guests and they have kids that we can't mute. So here is a good link. I shared the link in the chat window. So if you want to get yourself familiar with failure scenarios, this is a good link. I'm going to get back to it tomorrow when we'll talk about stretched clusters. So you have failure scenarios here with few examples. One failure, red one, okay, it's going to happen. We lost one host. Durability component is created. We will wait 60 minutes. Passing the 60 minutes, we will start rebuilding. Okay. You can also see examples of with 5 in an environment with 5 hosts. Let's see what's going to happen. We lost one host. Durability component again. Rebuilding after 60 minutes. Okay. So you have plenty of scenarios here. So you can see exactly what can happen in case of here's a simulation showing the durability components and how the resync happens. Okay. Okay, so that was a quick look at the state. I will get back to the 60 minutes and talk a little bit about it.